Hello, this is Scholar Stripe doing some math today in geometry. We're going to be looking at isoceles and equilateral triangles. So first we have the base angles theorem. So if two sides of one triangle are congruent, then their base angles, or angles opposite of them, are also congruent. Okay, so let me flip this over. Let's say that was congruent to that. That means these angles are congruent. Okay? So if sides are congruent, then the angles are congruent. And then backwards, well, it's basically the same thing. If these base angles are congruent, then those sides are congruent. And then if a triangle is equilateral, then it's also equiangular. So if it's equilateral, that means it's also equiangular. And then same thing, if all the angles are the same, then it works backwards. It's also equilateral. Alright, let's use some of those facts here. Identify two congruent angles. So that would be angle F and angle G. Because these are the base angles. So those are the two sides. That means the base angles are there. Opposite of the F angle and opposite the G angle. Find the measure of RST. So we know all the sides are the same. So all the angles are the same. So we just need to find one of them. And we know that angle R plus angle S plus angle T equals 180. So we're going to just divide 180 by 3. And we'll get 60 degrees for each of these. Alright, find the value of X and Y. So we know, trying to see here, let's see. Okay, it's a little bit hard to see here, but we have this angle, and then they kind of confuse me a bit, but this angle there. So this angle, and that angle. So we're looking at the big triangle. Since it's equiangular, we know that x equals 8. So x equals 8 because triangle KJL is equiangular. Therefore, it's equilateral. Okay? And we know triangle MJL. Okay, so MJL is isosceles. Okay, we know it's isosceles because this angle here is congruent to that angle here. Okay, that means this side and that side are the same. So if x equals 8, then, and since those two sides are the same, I set them equal to each other, 8 equals 2y, so y equals 4. Alright, diagram shows a piece of quilting. Explain why triangle ABC is equilateral. So we want this blue triangle here to be equilateral. How do we show that? Okay. So we know, let me use a different color. So I'm looking at the bottom triangle here, ACD or ADC. So we know that these are congruent. That means the base angles are congruent here and here. And since these angles are congruent, this is an equilateral triangle, which makes this side the same as all these sides. Okay, so we proved that. And they told us that this side is congruent to this side, which is congruent to this side, which now is also congruent to this side. Okay. We know those two sides are congruent. That means this angle is congruent to this angle. So we know it's isosceles. Let's see. How do we get that last angle? Oh, sorry. I just noticed that, yeah, we were supposed to show that ADC was equilateral. I already did that. So, show that triangle CBA, I guess that's what I was working on. So, show that the top triangle is congruent to the bottom triangle. Okay. Oh, well, that's a lot easier. So, we know that these sides are congruent. And we know that these base angles are congruent. So these two, so we have two angles, and we have two sides. So you could use angle side. And then now that we know that those two triangles are congruent, they're both equilateral. Okay. Checkpoint 1. In example 4, show that angle bad is 120. So since we know that both of those are equilateral triangles, that means each angle is 60 degrees. And angle bad is just angle BAC plus angle CAD. So 60 plus 60 equals 120. So we have to show it. So we have to say angle BAC is equal to 60, angle CAD is equal to 60, because equilateral triangles. So because of equilateral triangles, because they're equilateral triangles, all the angles are the same, so they have to be 60 degrees. And there you go. If FH is congruent to FJ, so if this whole line here is congruent to that whole line, then which angles are congruent? Well, that would be angle H and angle J. Well, that was quick. So I'm just looking at the big triangle here. We got that going on and that going on. That means the base angles are congruent. So if triangle FGK is equiangular and FG is 15, then what is the length of GK? Well, since the triangle is equiangular, it is also equilateral. Therefore, GK would also be 15. And that is all I have for you today, I think. Yep. Have a good one.